So the things that we do here, we do several different types of events. At the bare minimum, we usually do 2 meetups a month at the very least. We are talking about possibly doing an online third one. We haven't really decided on that one yet, but it's in the works. We also do a cohort program. Our cohort program is essentially the idea of we put junior developers or people that are trying to break into tech on a team. And they can't necessarily be a beginner. They got to be much further along the line in the process. But over the course of 6 weeks, we have them work together building a project that's actually worth talking about. And they're being guided by a professional software developer that works in the industry. This cohort, we have 26 volunteer leads that are all professionals. We have some professionals that work for FANG level organizations, and we have some that are working for small level organizations that are local, right? I think equally, they're all incredible for giving back to the community in whatever capacity that they can, because they don't make anything off of this, but neither do we. Our cohort is 100% free. We don't charge a dime for it, but the ultimate idea is to get developers working on something at a higher level scale, using enterprise level methods and solutions, but really kind of lifting them up, so to speak, in regards to like technical abilities. Even some of our cohort members are here tonight, right? So if the cohort is something that you're interested in the future, we're probably going to do one more this year. You can go to dallassoftwaredevelopers.org and sign up to be notified for that. With that being said, we are a local meetup group, especially for those online. Dallas citizens will always get a priority in the selection process versus others, but after that, it's kind of open globally. This cohort, I think 25% of the cohort members are international or from other cities and states. The vast majority are in the Dallas area for that. The other housekeeping item, just out of curiosity, how many people in here have heard of the Commit Your Code conference? How many people have not heard of the Commit Your Code conference? All right. We decided last year to do a tech conference. I've always had the idea of doing a tech conference, but I'm not really attracted to the idea of like just doing it for money. It doesn't really get me going. But I had this idea in like August of last year to do a tech conference where the barrier to entry isn't the fact that it's income related, but it's if you want to go or not. And so what we did was we got put on the conference. We did it in less than 3 months, to be honest with you. It was like 2.5 months to get it all going. We had almost 400 people attend in person, and we had 64 speakers. We had 3 tracks. It was phenomenal. We had almost 400 people attend in person. We had 5,500 attend online. We're doing it again this year. It was going to be a one and done thing, but we're doing it again this year. September, end of September. You can go to commityourcode.com for more details. Tickets start at $30, and 100% of all ticket sales are donated to charity. We don't keep any of it. So the goal with the conference isn't really to make money at all. The only difference between a $30 ticket and a $100 ticket is how much you want to give to charity. With a $30 ticket or a $100 ticket or $500 or whatever you want to give, 100% of all the ticket sales will go to charity, but your meals are covered for both days. Your experience does not change based on how much that you give. We wanted everybody to take part in the conference and feel the exact same way. As of right now, it's looking like we're going to have well over 100 speakers this year. Last year, we did 3 tracks, Java, JavaScript, and Cloud. This year, we're adding a 4th track of .NET. And so it's going to be a big one. A lot of companies actually ended up sending out their developers here. So if you work at a company, that could be something that you put on your radar. I know a lot of companies kind of axed their education budgets after the pandemic, unfortunately. This is kind of a way that developers can attend a conference without really having to rely on the company budget. Maybe just don't make them use their PTO. That can kind of be a way that you can kind of facilitate them attending and skilling up. We're different than the traditional tech conference. We do a lot of different flows and different experiences. We have a lot of workshops and things like that worked in there as well. And there's no cost for the workshops. It's all included in that $30 ticket. Did I miss anything? Oh, I did miss something. So if you enjoy the talks tonight, you can easily check out our YouTube channel, Dallas Software Developers. Every meetup that we've ever done that has a technical theme, it is recorded and placed on that YouTube channel. So if there's talks from the past that you wanted to visit, even the conference talks from last year, or last year is December, 3 months ago, they're all on there as well. We stream the entire thing for free, and the talks this year as well will also be put on that YouTube channel. So if that's something that you want on your radar, highly recommend checking that YouTube channel out. Outside of that, I think we're good. The last housekeeping item, introducing who we are. For those that don't know who I am, I'm Danny Thompson. I am known for running my mouth on social media, but on top of that, I am a organizer here for Dallas Software Developers Group. When I came to Dallas, it's been almost 3 years, 2.5 years. I wanted to do a meetup group, and we kind of brought this thing to life. And so I wouldn't be able to do this without the support of all the volunteers that we have. People need to know Dennis Garcia. He doesn't get enough attention sometimes, but Dennis, he went above and beyond this year. And that's kind of how we have all this audio equipment, the visuals. So online, your experience is a lot better just because of that alone. We wouldn't have it without him. So big shout out to Dennis. Yes, seriously. Not only is he an admin, he's also leading one of the teams as well within the cohort. I'm also leading a team. Several of our admin are. It's just our way to kind of give back and keep things going. Also want to give a shout out to our other admin tonight, Arjun. He doesn't know, I'll call him out. There you go. Arjun, he's been volunteering and helping us out. He actually does work at Yum Brands, but this is kind of his way to kind of give back and stuff like that too. He's been really valuable, and we genuinely appreciate having you here. Other admin that can't be here tonight, I don't know if Clint is here. I didn't see him, but Clint, if he's not here, he's been helping out, very active in the Discords and coming to the meetups. Eric Anderson, for those that don't know, he has the name, the happiest software engineer in the world. So he's really, really cool, a very great individual. I was so glad to have him on the team. Several others as well that can't be here tonight, but it's really the effort of a lot for us to get here. So shout out to them. With that being said, let's kind of get this thing started. I've been running my mouth long enough. So we're going to give it up for our first speaker first, Aly Ibrahim. He works at Microsoft. I got to fix that.
Woo! Okay, hi everyone. Thanks for waiting on the technical difficulties. So we're gonna go first with my presentation. It's about like the basics, what you need to learn, how to go your cloud journey. So start quickly on my side. My name is Aly Ibrahim. I work for Microsoft. I know it's been there everywhere. I work for AWS, but that was past. I left AWS. Now I work for Microsoft. That was like 1 year ago. I work for AWS, for Red Hat, for Ericsson, Oracle. My domains are usually within Kubernetes, serverless, events, AIML, DevOps, multiple other things. So I know we're short on time, so I'll just try to go quickly, and Danny, let me know. Yeah, okay, cool. So first of all, why cloud? Why do you need to use cloud? It's reliable. So have any one of you heard of any cloud outage happened before? Oh, no, it happens. But what do I mean by reliable? That there is an SLA. Any cloud provider provides an SLA for their services. So even if the services are down, you can expect how much it can be down within specific time frame. So it's reliable. It can go anywhere, maybe in US, in Canada, in Europe, everywhere. You can rely on the same services everywhere. One of the other things is it's scalable. So you can start small and scale with you. It goes on from one VM to multiple VMs. You can scale it. You can go with, if you're working with functions, for example, the functions can scale based on events. And if there is not a lot of traction on your application, that you can scale down and just keep your cost within limit. The other thing is efficient. So if you're using your own hardware, you need to do procurement. You need to go and buy your hardware, wait for the hardware to be shipped, install the hardware, do the connectivity, do all these things. That's usually used to take like from 3 to 6 months to be ready. And then developers start to put their applications. In cloud, you can do this in a few seconds or maybe in a minute. So you can deploy, be ready, test it. If your application, if you don't like it, if you don't like the ideas that you tried, just kill everything and you didn't pay anything. So it's efficient and let people go fast and quickly. And it's for every size. So cloud is for individuals. We got lots of developers here, like to do personal projects. So instead of waiting on your servers or asking for servers from your company, you can just go ahead, do personal project, maybe do trials for your work. If you want to monetize your application and you have like a small API that you built, you don't want to put servers running all day, all 24/7 just for few requests coming to your application. So using cloud can help you monetize your APIs, can help you monetize your work. And at the same time, it doesn't cost you much. Sometimes it doesn't cost you anything. And of course, you can learn. So you can use cloud to learn new services. All of us, of course, heard about AI. So if you want to test with AI, learn AI on any other services, you can do that as an individual. For startups, for example, most of the startups start very small and then they grow. So without having to need to bear for all the hardware, they can start with small on the cloud and the cloud will allow them to grow. Have you heard of Pokemon Go when they start and they went all crazy. All of a sudden, next day they grow crazy. Everyone in the world was using them. If they weren't on the cloud, probably they would have been crashed. So cloud is helping to scale and grow. And of course, for your enterprise, if you're working in big enterprises, you need cloud to do migrations. They rely on cloud for managed services. If they're having databases in the cloud or anything like that, they rely on managed services for them and to modernize their applications. So it's for everyone. Some categories of cloud services are infrastructure as code, infrastructure as a service. This is where you can just go to the cloud, maybe rent a virtual machine, request a disk, some basic compute services that you can get of them. These are called infrastructure as a service. The next step will be platform as a service. So you can run something like functions or Lambda as in Azure Functions or AWS Lambda. This is a platform that the cloud provider is providing to you and you can just use and consume. If you're using something in like Azure App Service, it can allow you to deploy your code, build your code, and even do all the CI/CD pipelines, do the authentication with just one click. Similarly with AWS Amplify, or maybe if you're more advanced or using something like Kubernetes, all the cloud providers provide Kubernetes as managed service and as a platform to deploy your applications. The third way of using cloud services is using SaaS services, like software as a service. And I didn't put any examples here, because the examples are a lot. Like OAuth, for example, is a SaaS provider. Azure, we have like Azure Fabric, which can allow you to use a complete solution just by logging into that solution, subscribing to it, and it will give you your own tenant, and we start consuming this as a service from the cloud. So 3 things: infrastructure, PaaS, and SaaS. If you're new to the cloud and you want to learn, there are basics that you need to learn. And when you learn those basics, can make your life easier. Because a lot of people, especially developers, they just go and put the code in Lambda or put the code as a container and that's it. But there are some basics that can let you move easily across all the cloud service providers, the cloud services that the provider is giving you. So if you can learn about monitoring will be like one service that can cover all the cloud services within the cloud provider. Identity, you need to understand how each service is secured, how the role-based access of each service work. So how this maybe Lambda functions can speak to the S3 buckets, how Azure functions can receive events from maybe service bus. Understanding these roles and which one can speak to which service can speak to each service, that's called identity. It's called IAM in AWS, for example. In Azure, it's called Entra ID. Understanding this role-based access control is very important to let you understand all of the other cloud service providers, because that's one of the most issues that we get. Other thing is security, and I'm speaking security in general. Third thing is networking. I know not a lot of people like networking, but understanding networking can help make your life easier. If you're using PaaS, for example, or SaaS, maybe networking is hidden underneath and you don't need to do much with it, but it's very good to understand networking, especially when you're working with VMs. The basic and the only free service that the cloud providers are getting forever is networking. Okay, next step is to be cloud native. So now you're in the cloud, you're trying to build your application. So how to be cloud native? As a developer, you need to do 12-factor applications. There are 12 factors that you need to put your applications in to be more cloud native. One of them is exporting your logging, exporting your metrics, and a lot of other things. Try to build your applications in microservices, whether it's using containers or using events or using serverless applications. Try to rely more on microservices and try to externalize common services as backing services to all your applications. If you're in the cloud, try to build your applications, your services to be immutable. Like each service needs to know that it can be killed at any point of time. It can be spun up again at any point of time. It can scale. So they need to be immutable. The state should be stored somewhere else away from the service itself. And last thing is automation. You need to automate all your code, all your deployment, all your CI/CD. I will speak about automation in the next slides. For building applications while developing, to consume the services, first you need to have your API mindset built into your applications. So when you're building applications, think of APIs and deploy each API as a service if you can. Use containers and functions as we mentioned. Consume queues, blob storage, NoSQL databases. These can reduce your cost and make your application more loosely coupled, and they are not depending on each other and more immutable. Try to delegate authentication and authorization and identity management. You don't need to write the code business logic yourself. There are services that can provide this for you and for free, so consume them. Again, consume more pay-as-you-go services, so in case of applications that are not really used and not really monetized, pay-as-you-go can be very well saving you. Like, I built a complete product and I was selling that product, and after some time I left it and moved to Microsoft. I totally forgot about the product running on AWS currently, and it's just costing me maybe $1.5 a month, complete, all serverless. So good that I didn't do that, and you see that meme of getting poor with the VM running on AWS. Last thing is, try, if you have like front-end application, I know we have a lot of front-end developers here, try to use static web pages to deploy your application. You don't need to have something running. You can use S3 or you can use Azure Blob Storage to just deploy your application from there, and it's the cheapest way to do it as well. I want to speak more important on automation. We just give a quick hint about it, but if you're in the cloud, you need to automate. Don't do anything in the cloud twice without automating it. So if you're doing one task the first time, if you see yourself doing the same task again, definitely think to automate it. And to automate things in the cloud, you can use something like infrastructure as code. You can even put your hardware, your infrastructure, application for your infrastructure within your code base. And there are tools for that. They can use Terraform. You can even use your development. There are tools like Pulumi, for example, that can allow you write your infrastructure in Java or your infrastructure in Go or in whatever, or even TypeScript. So that can allow you to redeploy the whole application, not just the code, but all the infrastructure attached to it, like all the functions, all the containers, all the networking, everything can be within the code base of your app. And finally, make sure that you have hooks in your application to build and deploy. Any changes you make, you push your changes to Git. From Git, this will help your application to get build and deploy. And the build and deploy services in the cloud are usually free. Even if you use GitHub or use anything like that, they are free for those kind of side projects. For company projects, of course, there are tools to do CI/CD and help you with that. Okay, so hopefully I didn't go over time. Few takeaways. So if you're in the cloud, new to the cloud, try to learn the basics that we speak about. Try to understand the free services and the cheap services that can help you run your application or your product in an easy and cheap way and doesn't consume much, and automate every step. Thank you. Yeah, don't forget to connect.
Hello, everyone. Good evening. Hopefully, I'm audible. So here I am going to talk about something related to AI, and I believe we are in 2025, and AI is everywhere. So that's where I'm talking about AI augmented data processing at scale, leveraging cloud computing for building these AI augmented data processing. I'm Jitender. I'm an inventor, did invention with AI, not now, a few years back. And I'm a fourth technology council member. I'm not audible? Okay. Okay. I'm working in the financial technology industry for last 17 years into software engineering, cloud computing, artificial intelligence. Worked at Walmart, SoFi, Capital One, and a few more banks. First thing first, disclaimer, the opinions expressed here are my own personal and nothing to do with my employer's view in any way and form. Agenda for today, we will go through this world of AI and how cloud computing has helped organization till date, and how we can leverage cloud for AI in this year and coming years. Building AI-enabled microservices and distributed systems, AI-powered productivity tools for developers and others, processing structured and unstructured data at scale, and what are the challenges with the unstructured data. So this is world of AI. It's divided into multiple pieces. At the top is artificial intelligence, and beneath that is machine learning. And as we go down, it's more complex, more intuitive, and more powerful. So we have neural networks and deep learning. And the top of the chart is generative AI, which is the talk of the town. So how cloud has helped organization till date? So we have this thing called infrastructure as a service and platform as a service. So if you talk of infrastructure as a service, cloud gives us or gave us on-demand compute, storage, networking, etc., etc. And if you talk of platform as a service, it gave us managed runtime environments like EC2, databases like DynamoDB and RDS, and Lambda for serverless computing, and CDN for static contained across multiple regions at or near to the customers. So what cloud has given? It has enabled innovative ideas with the empowering engineers and developers and companies to rapidly experiment with the small capital investment to build the solution as a prototype or deliver it as a MVP, minimum viable product in the industry, in production, with the enterprise grade foundations. And if you talk of now, this what I talked is what it gave at the start level. And eventually, if you are successful or you see your services are working fine, you can easily scale those. And it's like a matter of leveraging those cloud computing services and infrastructure to build this scalable solutions. And on top of that, what it gave us, which was not there earlier, transparency on how and what you're putting in the security policies and how you are using it, what type of cost you have with the billing at minute level and at higher level. And on top of that, it gives you a lot of insights on the metrics, like how your services are performing out of the box using CloudWatch is one of the example, but there are more. And what is the utilization of your services, like how much they are utilizing on the CPU and memory. And it's up to the developer or the team or company to enhance that or improve that, but they give you the transparency of upfront, out of the box. Now we will talk about how we can leverage or how we are leveraging cloud for AI. So what cloud is giving us is specialized compute instances like GPUs, TPUs. TPUs is a tensor processing units, is for TensorFlow deep learning workloads, and AI optimized processors. And with it comes the high throughput and low latency on the networking, on the processing. And as I said earlier, cost efficiency for even AI operations with the help of pay as you go, depending on how much you are using and how you're how your models are performing. You can swap them with least cost. And on top of that, you can use the instances, spot instances, for training your models when those instances are available, because they are cheap, but the timing is something which you don't control. And this is something which is more into night, where you can have your models running in the night when workload is less on the cloud computing platforms. And on top of that, cloud is giving you pre-trained model ecosystem like AWS Bedrock, SageMaker. Bedrock is all about giving you foundation models to try. And what do you call it? SageMaker is something which is giving you build a ML AI pipeline end to end to train and infer on the data. And it gives you the storage by storage already there, and it gives you the integration of these multiple services to have your end to end systems working for training and modeling, training and inference. And this is already there, and how we can build AI enabled services using microservices, following the cloud native architecture. And it gives you a lot of more power with model monitoring and performance tracking. And on top of that, you can do A/B testing for your models, how they're performing, not in non-production, even in production environments. And what it gives apart from that, if you talk of Azure, it gives you OpenAI APIs out of the box for your generic use cases, which you can leverage rather than building from scratch or building or train your models. And these comes as a different managed service, but the idea is to integrate with them is easy and effective and less time consuming. And the other piece is, I don't know how many of you are using it for development or not, but I use it a little bit, not much. So this is like all about developer productivity. It helps you do the code generation and completion. And yeah, it helps a lot on the automated testing generation, which you can, again, the caveat here is you should understand what it gave you, and you can ask AI like what it gave you and how you can understand that easily. That's again on the AI. And data processing. We have data which is structured, and let's talk about the structured data. It gives you serverless ETL workflows out of the box using multiple managed services or infrastructure as a service. Real-time streaming processing like Kinesis and managed Kafka clusters. And like if you talk of Google Cloud service called Looker, which gives you business intelligence insights on top of what you have in the BigQuery data warehouse. And this is something which is all about unstructured data, which needs a lot of, which is a challenge to process without any issues. And what we have right now in the industry is OCR, optical character recognition. It's all about how you process a document and what that OCR is doing on top of the document. The problem is it gives you the data, but it does not give you the accuracy. So if you talk of documents which are really important, this does not fit there, but which are not that important, and you can, or we can have some discrepancy, we can go with this particular solution. And this is something where AI comes again into picture, which is AI-powered optical character recognition for document understanding. So it has multiple pieces into it. So services like AWS TaxRect, again, out of the box, it gives you that ability, but you have to train your model on top of that. It's not that it will give you everything accurately, but the idea is it gives you a framework and pre-trained model to process your documents, train your model on top of service or platform as a service, so that you can build on top of that. And time to market is very important, apart from budget and other things. Okay. And this is something across the industry, which we call it object detection and classification. If you see, there are like 3 documents here, or 3 pictures here, and all are using YOLO. You look only once. So there are 2 pieces into this. First one is detection. Can you detect it or not right away? And this is not right away. The idea is it goes through a process where annotators annotate the missing pieces in a picture. and even put a annotation on that, what this means. And eventually and slowly, you train a model for your own use case. And yeah, thank you.
Does it look familiar? All right, good evening, everyone. What is Sherlock Holmes and Ethan Hunt and also Deadpool, what do they have in common? They're funny, of course, yeah. They're actually agents for hire. They are for hire, for on demand. When you need them, they'll be there to kill someone when it's needed. All right. So today I'm going to talk about agents as a service or agents on demand. My name is Ron Dagdag. I'm an R&D engineering manager at 7-Eleven. This is my workflow. I code, I create, I coach, and repeat. And these are the things that keeps me moving. I code and I create a space for experimentation. I teach people how to do stuff and then repeat and start over again. Of course, because I work for a big company, opinions expressed here are my own. All right. Since this is a cloud conference or a mini conference, I'm going to talk about the difference between IaaS or infrastructure as a service, container as a service, or function as a service. Anyone familiar with this or have seen this before? You kind of understand a little bit of what, when do you use infrastructure as a service versus function as a service or platform as a service? Most likely for us who have worked with the cloud side, have experience with this and had to choose at some point, right? Which one are we talking about? So what is agents as a service? Agents as a service sits between platform and SaaS, right? So, you still need to build your application, right? It's not like your software as a service. Somewhere in between that, where the cloud manages the application runtime, the containers, and everything in between. And that's what we're going to be talking about today. So what are AI agent? There's three things that it can do. You create the plan, retrieve a context, and perform an action, right? The create plan, you're using large language model to build up the plan. And then also you're using large language model to figure out where to retrieve the data or the context that it needs. And then also you're using large language model to perform the action, which action it's going to take and all that. Of course, this is the usual chatbot application where user may be asking how many vacation days has new employee. And of course, the chatbot is going to look for the knowledge base, whatever data that it has, and then it would receive the response. So it's limited. How many vacation days does a new employee receive? That's another one. This one is without RAG. And if you were here last time, for the agents, a lot of people have talked about RAG and retrieval augmented generation, which it looks at the data, looks at the documents or database or vector database. Without the RAG, it's just the data that you have on the large language model, just the same way as you ask ChatGPT without the search, right? It wouldn't do the search. So there's limitations there. And of course, with RAG, there's that component where it would have to search relevant context first, right? It doesn't have to be a vector database. It could be something else. It could be a file. It could be anything that can bring data to its context and then be able to answer it properly. So that's pretty much the whole idea with RAG. And this one, today we're talking about agents. What are agents? Agents have two sources now of data, right? So here's an example. If I have vacation days left, book 3 days for me and start it next week. There's the action component. And so what would it do? So the agent had to kind of figure out, where do I get that information? If I have any vacations that might connect to a database or might need to search or look at storage. And then it produced the action, right? It would book 3 days for me and be able to do that. And then it would respond back. So the benefits for it can perform extra complex tasks. It's action-based on the user input and knowledge-based business process and tools. And then when you start hearing about these multiple agents, where you have agents that are collaborating with each other, that each one of these agents have specific task or specific thing that it can do, right? A data agent can only read data. An HR agent maybe will be able to book through the HR system, and it has access to HR system. And then the booking agent be able to put it on your calendar and have your calendar invite. So multiple agents different are working with each other to perform the whole task. Okay. So there are three components on how you, or four components, how you would do this, right? There's things you have to provide knowledge, you have to provide agents in the right context, and there's actions. That means what are the tools that it can pick up, it can do in order to complete the task. Of course, you also have to consider security, because if it's an HR agent, you shouldn't be able to access HR stuff, right? And only limited access to the data. And then evaluation, any software needs logging, any software needs observability and all these different things. And that's what, a lot of the cloud vendors has been. Today I'm going to talk about on the Azure side of things, right? So let's talk about the knowledge side. It could be a Bing search, it could be Fabric, or it could be data or file that you upload. Action can be, a logic app or an Azure function or an open API. On the security side, of course, anything on user authentication on the cloud side. And then the evaluation, like I said, the training, tracing and monitoring, and then model flexibility in whatever models you wanted it to use. So Azure AI Agent Service, which is in public preview right now, that helps you kind of think about this as a function as a service. Works as an agent as a service, right? You have an application you want to build, you push it to this, and then they're responsible for kind of like Azure Functions or kind of containerization of it, or however it needs to run. And of course, you only charge when you use the application, right? When you call the agent. So the agent, you would need an agent, and then you need tools for that agent, and then you need threads to manage and kind of figure out, the conversation itself, kind of like a session, right? Because every chatbot application have to have a session. We don't want to mix everyone's session, right? We want each user have their own session. And then, of course, the activation run, perform the task and thread or configure tools. So 4 steps you would do this if you're going to do AI agent service. One is first you create an agent, then you create a thread, then you run the agent, and then check the status, because some agents takes a long time. So think about it's a background process that would do stuff. And then once it's done, you display the response. And then you can do it over and over again once you connect with the thread. So there's, of course, considerations. It's like, what is the instructions? What is the system prompt? And then you specify the model, and then you specify the data that the model would use, and also the tools that it can use. And then the thread would be the conversation in between, and then goes the loop to create a new message. You receive the response, create a new message, receive the response, and that's it. Let me give an example of what that looks like. I know I'm running out of time. I only have limited time, so I can talk about it later. So this is Azure AI Foundry. If you're not familiar with it, Azure AI Foundry, anything related to AI agents or AI, language models, generative AI stuff. This is the AI Foundry is what you can use for. You can do prompt fine tuning, prompt flow, and all these different templates. But I'm going to demo the agent side of things. So you have these. So the quickest way is you create a new agent, right? And you figure out the instructions. Like this is a search application, or set this assistant for question and answering and all these. And then what I did was to upload a file. I've uploaded a file, which is a handbook, and then some configuration. I'm not going to add a tool here, and then I can test it out. So try it on the playground. Let's see if it's going to work. I can just say hello, right? And then it'll go through that loop. So I have a session. It has a thread, has a session. It will get, and then I'll say how many vacations for a new employee, and then it would search that that file or that knowledge it creates a vector database, and then it would give you the results. And then of course gives you the link to that part of the document. So you can call this as an API. So here's an example of what that looks like. You can actually run it in see if I can get this. I know it's a whirlwind of stuff that I'm showing you today, but it's interesting so far, right? Yeah, so so this one is in Python. This is a Python notebook. Of course, there's libraries that you can call these. It's just an API call at this point to create an agent. Of course, there's a connection string in order to connect it to Azure AI Foundry. And so once you have that connection string and all the environment, this demo, let me run it first, and then it might make sense to that. And then we'll go through. So right now it's creating an agent, then it creates a thread, and it created the message. And then based from that message, see, it's running right now. The agent is actually running. I got value for what the email is going to look like. So it's supposed to send an email, and then after it's done, it deletes the agent and then gives you the thread message. So that's what's happening here. The interesting part of this one is these are tools. It's creating a tool. It's called a code interpreter tool. So the code itself is here. It's uploading it to the cloud and runs it when it needs it, right? So a lot of us here, do you all hate documenting your functions or your methods? If you're going to create an agent, you have to document it. You have to document what are the parameters. And this is the important thing if you're going to do code interpreter tool. Why? Because the agent won't know how to call it. You have to describe it well. So if you describe it well, then you'll be able to understand what it's trying to do, right? And once it knows what it tries to do, so here, this is the instruction for the agent, and you're specifying here, hello, send an email with the date, time, and weather information in New York. And so what it'll do is send this message. It will go through and say, is there a function to fetch the time? Is there a function to be able to fetch the weather? And is there a function to send the email? So it created a plan, step-by-step plan in order to do that. And once it's done, it's gone. It deleted itself and it's ready to go again and deleted the session and all that stuff. Interesting so far, right? So the different steps where it can do in order to create the agent without, it's agent as a service. You do its task and then it's gone. That's it. That is my presentation for today. Thank you very much. And thank you very much. If you need to contact, the best way to contact me is through through LinkedIn. So you can add me on LinkedIn. Thank you.
All right. I apologize for the people in the back. I'm about 3 apples high, so if you can't see me, I forgot my step stool. Sorry. So everybody's sold on the idea that the cloud is the best thing in the world. We all want to go there. Now, by a raise of hand, who here has participated or even just been part of in any way, shape, or form of a migration of an on-prem to the cloud? Raise your hand. Okay. Now, keep your hand raised if that data was clean and well organized. Yeah. Most of the time when you're doing a migration, you're taking like a dumpster fire and you're trying to lift it, and then you're trying to drop it in the cloud. And your client thinks that this is like modern work. It's going to be innovation. We're going to start AI, but you're just storing a dumpster fire somewhere else, essentially. So 80% of migrations to the cloud fail to produce the ROI that your clients actually expect. Most of the time when you're shifting to the cloud, the client thinks, oh my gosh, we're going to save so much money. Everything's going to run so much smoother. We're going to have way more capabilities. And then what ends up happening is the costs skyrocket and they freak out. And they're like, oh my God, we need to move back to the prem. The performance may even dwindle and get worse than it was. And innovation suffers. All of their big plans with AI just out the door. There was a Flexera study that said that 28% of the cloud costs is just waste cost, just overuse, ill-planned use, inoptimized storage. It's just a mess. And that's 28% of your cost. Now, who here has had a client complain of the cost of the cloud? Yeah, pretty much everyone, right? It's top of mind. I've even had some people say, the future is the prem. It's not. It's really not. Don't do that. So essentially, doing a lift and shift is like taking a race car, upgrading it from a sedan, putting regular in it, and then putting it on a dirt road. What you're going to end up having is just a really slow, chaotic, muddy mess to show. It's not ideal, it's slow, and it's not going to fix any of your problems. So the lift and shift, what I like to do is I take the F out of shift. I'll let you reread that sentence on your own. So most companies are treating the cloud like a storage, right? It's like taking every DVD you've ever owned, uploading it to the cloud, and you're like, great, I created Netflix. You know, I'm the wisest person on earth. No, you're just using an expensive storage space. That's what you're doing at this point. So you end up paying for idle computing, right? Because there's no auto scaling at this point. Yes, the cloud is pay as you go, but you just took, again, a really, really heavy 1999 RV and you dropped it on the cloud. It still weighs 10,000 pounds. It's inefficient in terms of storage. There's no containerization. You know, you haven't optimized your storage for what should be in the blobs or what should be on Foundry or whatever your plans are, right? You're just lifting it and then dropping it. Most of the time it ends up being in SharePoint. And I mean, I'm not going to go down that. No. And then there's unnecessary data transfer, right? A lot of these companies, especially enterprise level, most employees don't even know how to do, you know, I do a lot of tech training, and just this week I had a company that I was working with and I said, where do you store your files? And they said, well, we don't really know. I mean, I create a Word document, I save it, and then I can't find it. And I navigated them to their OneDrive, and they're like, I've never used the OneDrive. And I said, yes, you have. They open their OneDrive and they're like, oh my God, Pandora's box. Everything I've ever created is here in version 1, version 2, version 3, version final, version final 3. So companies who are actually cloud native, and you can be on-prem and migrate to the cloud, that's fine. But there's a difference between a lift and shift and cloud native solutions, right? We're talking about an infrastructure that is beautiful, it's sexy, it's built for the cloud. You're not just lifting data and dumping it. You're analyzing all of your data. You're deciding what should be moved, what shouldn't be moved. And when it is moved, you are re-annexing it, you are labeling it, like you're really giving it some underlying data or information. Companies that optimize for a cloud native architecture are 3 times faster in terms of innovation, and they save on average 40% of operational costs. Now, this is average, but I've seen companies save millions of dollars by doing this properly. So the bigger the company, the bigger the cost savings. So obviously AI is a big subject. Everybody wants to talk about AI. It is the future. I'm an AI engineer. I'm not going to say that it's not. It absolutely is. The issue is the market is about to get flooded with a lot of crappy AI models, like really bad AI models, like the Copilot chatbot that was dropped on SharePoint. I hate it. It's horrible. Everybody's building them. They are useless. Like, you ask it, how many PTO days do I have? And it's going to tell you that Nancy's making $80,000 a year. and that you should be jealous. Like it's just completely useless, but that's what most people are building at this point. So in order to really use AI, we can't just do the migration. It doesn't work anymore. The drop and shift or whatever you want to call it is just not a solution. If you do it, you're just going to end up with a mess. You're going to build one or two little, agents or chatbots, and then your whole system is going to start basically barreling down, and you're going to have to go back. You're going to have to re-architecture your entire cloud and start over. So if your company is asking for, a migration, do it right, because that way, when you build beautiful, smart AI models, the data will be processed in real time. It will allow you to scale inferencing much more easily, and it'll power the next wave of innovations. So my big thing is dynamic AI architecture. If you look at my session eyes, most of what I talk about is this. And dynamic AI architecture is what I call the saving grace of the bad AI agents that are about to flood the market. So you're looking at a model that is cloud first. Don't ask me to build you an AI until I've cleaned your cloud. It's not fun, but if I haven't cleaned your cloud, your data is a mess. Show me your data, I'll show you your AI model, right? It's kind of like a woman. Whatever you give her, she amplifies. You give her a little bit of love, she'll make you a baby. You give her shit, you better walk away, right? Same thing with AI. If you give it really nice, intelligent, well-organized, labeled data, you're going to get marvelous results. You're going to get fantastic models. And not only that, your models will be able to scale and grow and innovate. You're going to be able to create what I call ensemble models, right? So a dynamic AI architecture is cloud first. It is statistically wise. So we're using, Bayesian models, we're using Markov chains, we're using everything to come to the most accurate predictions humanly possible, or AI possible. And it's based on a really intelligent cloud architecture. So for every statistical model that you have sort of like in a row, you can then go back and point an API midway through, pull that modified prediction, and then move it to another model and get another response, right? So we're talking about AI architectures that, become like ginormous decision trees, but every node is an AI model, essentially. So a really good example of this is patient deterioration prediction models. If you're doing this on a lift and shift, your predictions might take minutes or at worst hours. If we're talking about healthcare, seconds matter, right? So it's a huge difference. And if you're looking at servicing your clients, well, you've seen how patient your online buyers are, right? So just a couple of extra seconds can actually cost you a lot of money. So an example of this is my little AI chess robot. So you're going to use a really, intelligent cloud architecture. It's well built, your model's well organized, and then you're going to run it through a Bayesian network to help it predict what your opponent's next move is based on past patterns. And then most people would just stop there, right? That would be their chess model. But if you really want to be smart about it, you then run it through a Markov chain, because then it's going to navigate the game by choosing the next best move based on the state of the current board. And then finally, because again, you're not satisfied with the easiest, of models, you're going to move it to a Bellman equation. And it's going to help create an overall winning strategy based on long-term moves versus short-term moves and everything else that has just predicted through the Bayesian model and the Markov models, right? So that's where you get really intelligent AI systems, but you cannot do this if you haven't organized your data and your cloud to be able to allow this to happen. It's just not going to happen. So that's it for that. My name is Samantha. I'm a AI engineer and solutions cloud architect, and a technical trainer. And if you'd like to connect, I have the QR code. So come join me on LinkedIn and let's talk more.
Good evening. I tend to walk, so that light's incredibly annoying. My name is Dave Strickland. I am a cloud evangelist with CG Infinity here out of Dallas. I will put the slides up online. That's my LinkedIn there. If you'd like the slides, feel free to grab the LinkedIn. As I was prepping for this, I was getting kind of concerned. I got like 10 minutes, right? And I'm going to try to cover how to migrate from on-prem to cloud in 10 minutes. And I'm going, yeah. Which reminds me, let me start my timer here before I get going, because otherwise I'll run right past it because I'm old and I tend to talk. And then I get here and I find out Samantha's going to prep for me. And she's going to lay out why lift and shift doesn't work. I started talking about cloud probably 2010, right? I mean, we had S3, we had CS2, we had compute, and we had storage, and I'm trying to sell this to clients, right? And so I hit on all the same stuff that we've already all hit on, right? I hit on the cost savings, right? You're going to save so much money. You're going to be scalable. It's going to be reliable. You're going to be able to recover, right? If you get an outage, it just comes right back up. You're going to be able to integrate with all these great AI things that we've already talked about tonight. Of course, I didn't say that back in 2010, but hey, I'll bring it in now, right? That's like the goal of cloud. That's like why we do it, right? And so I'd get up in front of these executives, I'd get up in front of these managers, I'd explain all this to them, and I'd get the bobbleheads going. They'd start, yeah. I'm like, okay, let's do this. And they're like, wow. Let's move your SQL server to the cloud. What can we do that's small? Well, we could do a function. Yeah, let's do a function. You want one function? Yeah, do one function and then get back with me. Let's run an experiment. Okay, that's what this always led me to. An experiment. And then I get that one done and okay, we'll do a bigger experiment. And I'm like, guys, AWS has released 37 services since we talked last, and we're still working on Lambdas here. Okay. You know what I found out actually kicks off cloud migrations? Your data center contract is up and they don't want to sign another 5-year data center contract, right? Our lease is up on the building. We've outgrown the building, or we all decided to work, we're going to all work remote. So we don't want the building anymore, right? These are for like the last 5 years. These are what have kicked off almost every cloud migration I've heard about. But the difference between these and all the stuff on the last slide is these all have timeframes. The data center contract's up in 90 days. Can you get us the cloud in 90 days? Well, you've been telling us how great it is. Come on, the first time I heard about a lift and shift, I was like, why in the world would you do that? I mean, you get nothing out of it. It's nothing but pain, right? I've actually worked with companies, been in the dev team, came in Monday and found out that they lift and shifted over the weekend. Didn't even talk to the dev team. So what is a lift and shift? And if anybody's out there don't know what it is, this is a real simple version of it, right? You go around your data center, you count all your servers, you count how many processors you have, how much memory you have, how much hard drive space you have. You do a backup of each one of your servers, you go out to the cloud, you create a VM for each one of these things, you restore your backups, you change your DNS, you're done. Everybody goes to the bar, has a great time. We're cloud native. No, you're not. Right? See, the problem with that is invariably 3 months later, the CFO comes walking into the dev's office. Why it isn't the infrastructure guys, I don't know, but it's always the dev. They walk into the dev's office and they're like, you told us we were going to save money. I just got the Azure bill. At this rate, we're going to go right past our OpEx, right past our CapEx, and we're going to be long into salary before we ever get this thing paid over this year. And it's like, yes, of course you are. You've not done any of the things that cloud is good at, and you did everything that the cloud is bad at. The average data center, right? For the last 10 years, we've been fixing problems with hardware, right? Oh, we're not performing, get a new processor, right? Oh, you're running on memory, buy new memory. More hard drive space, it's cheap. Hardware's cheap. Just keep stacking hardware on it, it'll fix it. Moore's law, as long as our growth rate isn't outrating Moore's law, we're good to go. And then we migrate to cloud. And we make a VM the same size of this monstrosity of a IIS server that's got memory leaks, and we shift that whole thing up to the cloud and can't imagine why we're paying so much money for it. The average data center, 40% is all you ever use of that. Now you're gonna peak, yes, but on a median day, on a normal average day, you're only using 40% of your server, and some estimates bring it all the way down to 20%. That's the median utilization of a hardware server. Now, of that remaining 20%, of that 20%, 40% utilization that server is actually doing something, another 40% of that is just pure overhead. That's the operating system, right? That's all the back-end services. So the only thing your company is actually using is about 28% of that server. Now you're paying for the whole thing. You're depreciating that whole thing over 3 years, but you're only actually using about 28% of it. And that's where your cost savings comes when you go to the cloud. The only thing you want to move is the 28%. The only thing you want to move is the yellow. You don't want to move the blue. But when you lift and shift, you're moving the blue. This isn't so bad on a lift and shift, but this is nightmare on a hybrid. So the other thing you pay for in cloud is your data transfer. You can send data up to the cloud just fine. AWS and Azure, they want your data. Oh yeah, give us the data. We want your data. You get free, just bring it in. Oh, you want it back? Yeah. That's where you get cost. Your ingress is free, your egress. So we don't want to pay for a big SQL virtual server, right? Because we've already deprecated our 32 CPU in-house SQL server. So let's keep the SQL server in-house. Let's put the IIS servers up on the cloud, and we'll do a hybrid. Every request to the server goes up, comes back down to the SQL server. Data from the SQL server goes back up to the server, comes back down to you. You just paid for that same data twice. And your CFO is saying, why is this so expensive? Because nobody told you this. Because you just walked over to the infrastructure guys and said, can you lift and shift us to the cloud? Can we get to the cloud so we can get off of our data center? Yeah, we can do it. But nobody talked to the guys that are actually moving the data. All right, I'm running out of time. We'll skip right past data storage, hot, cold. You all know this. Hopefully, when you VM, it's all hot. There's no concept of cold storage. There's no concept of warm storage. Your IIS server is not going to sit around waiting for 2 days for that data to get out of cold storage to return the request, right? It just doesn't work that way. It's all hot. It's all expensive. All right, which brings us to how do we get from lift and shift? How do we get from on-prem? How do we go from lift and shift to cloud native? Now, these aren't absolutes, okay? I've really simplified this down, so please don't beat me up later. You start off with your lift and shift because you have to. Your data center contract's up. You've got no choice. You've got to lift and shift it, but you can't stop there. You have to keep moving, right? Your next easiest step, the next easiest thing to do is start replatforming. I mean, if you backed up your SQL server and moved your SQL server into a VM, get that thing over to a Microsoft Azure SQL server, right? Get your MySQL server over into a cloud native version of that MySQL server. Those are designed, they are tailored to use the cloud correctly. Don't run a VM housing MySQL, right? Get that over the cloud native. Don't run an IIS with an API on it. No, web API that thing, right? Web app your applications, your internet applications. There's the word I'm looking for. Get those replatformed. That's what replatforming is. It's taking something that's designed to run in a in-house environment and moving it into the cloud native version of that environment, right? A lot of times you don't even have to change the code. You don't even have to touch them. Sometimes you do. There's minor things here and there, but for the most part, these things just go right over, no problem. Now, you don't get as much savings, right? You don't get all of the scalability. You don't get all of the reliability that you can get when you get fully cloud native, but it's at least better than having a VM running with Microsoft SQL running on it. Okay. Next, containerized macro services, right? Another big fun word. You just take the whole thing, wrap it up in a container. Okay. Don't worry about cutting it. Don't worry about slicing it. Just take the whole stupid application, put it inside of a container. Okay. It's a macro service. It's huge. Is it best of the world? No. What does it give you? It gives you some scalability, right? It gives you the ability that if that thing crashes to spin it right back up in Kubernetes, right? It gives you this ability to start moving forward, right? Once you get to your macro services, you've macro serviced everything you can, then you go to your microservices, okay? Start splicing those things up, right? Get every endpoint, get every request, get pages, start moving these things into smaller microservices that you can host independently. Now you're starting to get to scalability. Now you're starting to get to that level of cloud that we're trying to achieve, right? Because ultimately where you're headed is you're headed to serverless. That's where you're going to have to get, especially as Samantha told us, as we start working into this AI arena and we start getting agentic AIs, those agentic AIs need functions. They need lambdas. They need serverless calls in order to be able to interact with that agent. So that's where we have to get, and that's where every company is going to have to get in the next couple of years. And I am probably out of time. Yep. Serverless containers. Serverless containers are containers that act just like functions, right? You can spin them up now. You can look it up. They initiate just like a function or just like a lambda, but it's actually a container. The container spins up, does its thing, spins back down. Then finally, you can take that same exact code and move it on into an actual serverless environment. Okay, it's not that simple. Okay, I very much simplified it, but I wanted to give you a thought process, a way to see this as you move forward through your cloud native journey, give you some vocabulary, give you a way to think about these issues. Thank you.
Does that work? You guys hear me okay? All right. I'm going to bring you here because I need to read my screen because I'm blind. How's it going? My name is Justin Biard. I work at Oracle. I've been doing Oracle Cloud Infrastructure software engineering for about 3 years now. Tonight, I'm just going to talk to you about some nuts and bolts, so building in the cloud with Terraform. Hopefully it's new for some of you. If it's not for others, then maybe you'll learn a couple things along the way. Just a disclaimer, I work for Oracle, but my opinions are my own. It's my own presentation. So, all right. So what do I mean by building in the cloud? You've heard a lot about it tonight from others who presented. We're usually talking about software as a service, platforms, or infrastructure. A lot of what I'm talking about right now is really covering the concepts of infrastructure, but with Terraform, you can use it in different contexts. So why do we use tools like Terraform for building in the cloud? I think it's cool personally, but it also has, for me at least, 4 other general reasons that I like to use it. The first is that we get some nice abstraction with Terraform. So it's fairly low code in terms of development, and it comes with nice to have benefits like parallel execution. When you deploy with Terraform, you're actually deploying multiple things in one go, typically. And there's a nice concept of a dependency graph in Terraform where it works out things that are required to be done in a certain order. So that's really nice to have. Terraform brings reconciliation. So, you know, it's the concept of, I like knowing what my changes are going to impact in my infrastructure. So I have already existing infrastructure in the cloud. I make some changes in Terraform. I'm able to tell what the differences are going to be when I apply that new change. So you get some reconciliation with Terraform. Of course, that also assumes that all of your infrastructure is probably managed through Terraform. If you're doing things directly in the cloud service, not through Terraform, you're going to have some things that happen outside of it. But if you bring it into Terraform, you get that benefit of reconciliation. You've already heard, Aly mentioned this before earlier today, you get automation in cloud if you use Terraform. So, you know, doing the same work in a cloud provider's console can be a lot of mouse clicks. If you're going to deploy an entire stack from zero and build an entire region for your application, it's nice to have something like Terraform where you can quickly bring it all back online. It's a very automated tool. You just apply versus clicking in a console somewhere. And then Terraform, for me at least, brings comprehension. Like if I don't understand what's required to run an application, if the infrastructure that's required is all defined in Terraform, I'm able to go look at that and understand immediately, oh, this application requires this network setup. It requires this load balancer. These are the compute volumes that are required to run it. It's a very self-documenting tool. So it's really, really useful in that respect. At least those are the main 4 things I like about Terraform. All right, so I know you all had pizza already, and I'm sorry you're going to be a little hungry after the rest of this presentation. I just want to ask a survey of the audience real quick because I want some participation in this. Who likes a fresh donut? Can I get some hands? Who likes fresh donuts? Nobody? Really? All right, well, so tonight we're talking about building in the cloud. You already heard about the 3 big ones, but we're also going to talk about 25 years from now. I want to build in the cloud a service called Donuts as a Service, right? I'm at home, I'm like, it's 5 a.m., I want some donuts, but I just want to get it delivered to my house. So this gives us some context to talk about, theoretical, right? It grounds the presentation. What can we build in the cloud? Let's just talk about Donuts as a Service. There's actually no demo here. No donuts are going to show up. I'm sorry. All right, so why Donuts as a Service? Well, first of all, fresh donuts are delicious. I think a lot of y'all already agree with me on that point. And it's growing in popularity, and there's some studies out there that show percentages of growth, whatever. But it's also slow to start up. Imagine going into a new market with a donut shop. It just takes time. You got to build it all out, right? Everything's not there yet. You got to build it. So this is very theoretical. 25 years from now, when we have quantum teleportation, we'll get some infrastructure that supports that. So in conclusion, really, I think we can improve the future with Donuts as a Service. All right, stick with me. We'll get there. All right, so we need a recipe to build this out. So we need obviously some kind of infrastructure. Usually that comes with a cloud service provider. We need APIs to manage the infrastructure. And we need a Terraform provider to use Terraform with that API, right? Those are kind of the 3 things. Seems obvious, but when you say it out loud, you kind of get a picture of it. And then we're going to need a donut shop to provide their configuration. They have the requirements. How do you run their applications? How do you scale their infrastructure? They know what they need. So the requirements come from the donut shop, and they give that to us as infrastructure as code. All right, so in theory, at least, what is infrastructure as code? It's literally just your infrastructure described as code somewhere in a code base. So what kind of networking configuration do you have? What kind of policies do you require in a donut shop? How many drying racks do you need? Now with Terraform, one of the things you often need to do is plan your changes, right? So I've made some code changes. I need to plan the change so I can understand what impact that will have on the infrastructure. So when you do that, a Terraform provider is what that's called, will read from the cloud service to kind of give you a snapshot of what changes it's about to make into your infrastructure. That's important. Go back to that reconciliation concept, right? I need to know what it's going to do on my behalf. And then with Terraform, you apply those changes. And what happens is the Terraform provider will send commands to your cloud service provider that says, hey, manage my infrastructure, create my compute, create my networks, configure everything I need to run my workload. And that's really important. It's what saves you from having to do all the mouse clicks or run custom scripts against a cloud service. All right, so this is just code. So like any other source code, you should version control your infrastructure as code. A lot of times that may be in a code base. So if you have your application software written, you may have your infrastructure as code sitting right alongside that in the same code base even. You should version control, by the way, it's recommended. All right, infrastructure as code is often reusable. So for example, if you set up your Terraform configuration correctly, you might and you should be able to deploy this in a pre-production environment, use the same code to then deploy into a production environment, or across, if you deploy your application in different regions in a cloud service, manage infrastructure in different regions. It's very flexible in that sense. Also can be conditional. So for example, let's say you have a small region somewhere in the world that doesn't handle a lot of scale. You can have your Terraform configuration set up to scale down your infrastructure in that region. Maybe it's larger in other regions. Our typical use case might be your development environment. Doesn't need to be as big as your biggest production environment. So you can have Terraform be configured conditionally. Now, we're getting to the end of the theory here. So when Terraform state is updated, it's when you apply your changes to your cloud infrastructure. And then Terraform is able to read back those changes and save them into what's called the Terraform state. Now that information is either saved locally or it's saved in a remote backend. In some way, the Terraform state is tracked so that you can then get a difference of, hey, here's what I have today. When I apply this, here's what I'm going to have. So Terraform state is an important concept when you're working with these tools. All right, so that's enough theory. Let's actually look at how we code this. And I won't do a live demo. I'm sorry, Ron, you were too awesome. But basically, how do we code it? Well, the first step is we need to decide what kind of back end we're going to use. It's a very Terraform-centric thing. By default, you're working locally, which means your Terraform is set up to track state locally, right on your machine. You can also configure a remote backend, which means your Terraform state is somewhere centralized, and that way you can collaborate on it with other people on your team. We need to declare what providers we actually require. In this case, a provider is a Terraform concept that links your Terraform configuration to some functionality that you want. Often that's going to be a cloud service. You declare resources in the code. This is where you'll spend a majority of your time in Terraform. So you're actually writing down what are all the resources that I require in my infrastructure. Along the way, if you find out you need them, you can add variables to your configuration, right? There's bits of information that you can share across your Terraform code. That's pretty standard stuff in programming. And modules. Modules are great if you need to group large blocks of code to be able to reuse them across your configuration. That's helpful. And then outputs. Terraform has a concept of outputs that you can set up, and that lets you read values back out of, say, modules. So you can set up a very complicated thing in a module and just extract maybe one piece of information that you care about to use in other places in Terraform. Right, so we apply that and we get donuts as service. That's easy, right? We're done. All right, not quite. So in terms of putting hands on a keyboard, you're going to want to have a directory structure somewhere in your project. You create that directory. Inside of that directory, you create Terraform code. So it's text files on a drive somewhere, and you're coding that. In this example, I've got Donut Shop. It's just my root module of my project. And I have a kitchen submodule that we would set up. And that may have, you know, related infrastructure just for the kitchen part of my application. And I'm going to put that into a module. Now we configure providers in Terraform, sorry, a backend in Terraform using a backend block. So you decide if you're going to use a remote backend or maybe a service, you'll configure that backend through a backend block. In this case, I have an example S3 bucket. There's going to be parameters that you need to supply to say what bucket, where does it exist, all that. And then again, by default, it's local. So this is how it works. Then you need to declare your required providers. This is going to be where you say, hey, I want to work in Oracle Cloud or Azure or Google Cloud or wherever I'm working. I need to get their provider set up. So in this case, I've got the Bakery Cloud provider and it's version 425. It's perfect temperature. And I'm just giving Terraform the information to say, this is what I want to use in my configuration. Now, when I run a Terraform initialization, it's going to download that provider and I can start using it in my Terraform code. Providers don't come zero code. You have to configure them usually. So in this case, you're going to probably pass in things like, how do I authenticate my user to be able to run commands against my cloud provider? Generally speaking, just see the documentation for your providers. Like they'll have most of everything you need to know documented. All right, so now resources. This is where you're going to spend a lot of your time in Terraform. So it's very simple language. It looks a lot like JSON. It's not quite the same, but it's close. You declare resources in a resource block. You give it a type, an alias, and then you pass in some properties. That's really all the more complicated it usually is. Think of resources as things like your networks, your servers, virtual machines, typically are load balancers, whatever the resource is. Now, this is optional, but a recommendation would be to format your code. Terraform comes with a utility for that, so you can Terraform format. And just you do that before you check in your code to the repo, right? It keeps it consistent. Everybody's on the same page. You can create multiple resources of a given type by using something like a for each meta argument or a count argument. So if I need to create 10 of one thing, I don't need to copy paste it 10 times. I can tell Terraform how many of those things I want. It will do it for me. Adding variables, this is what you would do. You have a variable block. We give it an alias and some possible parameters. For example, variables can have a type. Is it a Boolean? Is it a string? What type? Is it an object? It can have a default value or it can be nullable. All right. Otherwise, variables can also be set up in a single Terraform file for use in a locals block. You just say, hey, I only have variables that I require in this Terraform file I'm working on. I'll create those inside of a locals block, and then I can do things with that if I want. All right, so adding modules to your Terraform configuration, you may end up doing this later on in your project. You might do it at the beginning, depends on how much kind of foresight you have into what you're doing. In this case, I've got a module called Kitchen, and it's got another Terraform file in it. And the good news is it's just more Terraform. It's not a new skill set you need to learn. You just create code inside of a file or a project directory within your overall project. And then referencing that somewhere else in my Terraform code, I just simply say module block. Here's an alias for the module, and here's the source for that module. And it will bring in the code from that module into your Terraform. You can pass down variables and settings, kind of make it parameterized so it can be reused pretty easily. It's also important to note modules can be done in a remote way. You can have remote imports of modules. It doesn't all have to be local, but it may be common for you to use a local module. Now, if you're refactoring things into a module, you might find that resources you've defined previously and deployed to the cloud already have an address somewhere in Terraform in the state. Terraform might lose track of where that resource exists in your configuration. So then you need to tell Terraform, well, this actually does already exist. I just moved it over here to this module, and you just need to understand the new address. To do that, there's a few things you can do. You can use a move block in Terraform 1.5 or higher. You can edit your state file, which is not super recommended, but you can use Terraform state move. Or you can import existing resources into your state. All those things are possible. So you can work around those kind of challenges. All right. You can make your modules conditional, resources as well. If you use a count meta argument, you can give it some condition and say, hey, if this is development, don't create this thing. Or hey, if this is production, create this thing. Or whatever your condition needs to be. In this case, a local variable saying, is the bakery enabled? Yes or no, and then create this kitchen. All right, outputs, this is how you define them. You give it an alias, you tell it what the value needs to be, give it a description, and then later on in your life, when you're in your main or your root module and you say, what, I need that value back out of my module. How do I get it? You say module dot whatever the module name is dot whatever the value you're exporting is, so that output name. It's also useful if you need to debug things from your root module, for example, just to get some state that you can read while you're working on Terraform. All right, so we've done all the configuration. We've created all of our resources. We've added our variables and modules. We're looking good. We do a Terraform plan. And that tells us, look, you're about to add 5 resources. You're about to change one thing you already had in your infrastructure. And by the way, you're going to destroy 5 things. So you should probably go check out what those things are, right? Just to make sure you understand the change. Of course, we know we're good. So we go ahead and hit apply. And then we get a report with a summary of what changed and how the differences came out. Sometimes you get errors, in this cloud. All right, so just to recap, Terraform gives us some abstraction. It gives us some reconciliation of our changes in our infrastructure. It helps us with automation. It makes that process of, look, there's a lot of clicks. If you're going to do a huge infrastructure build and you want to automate it as much as possible. So use Terraform for that if you'd like. It also gives us some improved comprehension. I get to understand everything I require. If it's onboarding or whatever the requirement is, I can understand my infrastructure just by reading the code. Resources are configured using a declarative configuration language. We need to configure backends, right? Where am I going to store my state? I need to configure my providers. What cloud service am I going to use? I need to configure my resources. That's kind of the basic workflow. And then I define modules or variables, and you can kind of rinse and repeat this process. Terraform is very good at being iterative in that sense. You can start small, work your way up in the code. And of course, last but not least, the future of donuts is donuts as a service. All right, here's some references in case it helps you in your, hold the claps, I'm almost done. Here's some references in case you need them. Like if you're new to Terraform and you're just trying to figure out how to get started, these are great pages to get a hold of and to start looking at. All right, and now I'm done. Thank you very much for your time tonight. I appreciate it.
Hi, friends. My name is Nishith Singh. I have over 14 years of experience working with Java, cloud, architecting and designing, developing solutions for different domains. Right. For the past few years, I'm working with the banking domains. And before that, I worked with IoT, social networking platforms. So this is a brief about me. Right. I'm also AWS certified and Java certified. But after a long day, right, I'm sure everyone is tired and now everyone's quantum. Oh my God. So I'm sure we need a morning time to elaborate and work and discuss this topic. But actually, like I reached, of course, I think few months back, I wasn't aware that what is quantum computing, to be very honest. And I'd like to just share one experience that how I came to this. And of course, it's like a 10 slides, but of course, I will be more discussing about is applications rather than getting into the core, because even I don't understand the whole core of this quantum computing, to be very honest, right? So how many have you used lip syncing recently or lip syncing? There's a where you have to sync your recordings with a lip, and you can just take any face and you can just put those recordings, and it can actually, like, even if you put your face, I can make you talk anything, even any rubbish thing stuff as well, right? So anyone have you used? Right. So so I was using it when I was developing a banker assistant, and then I used it, right? Then suddenly one day I thought, why I should use someone else? Let's develop my own. And it's a real experience. I just, though it's what you see in lip syncing, let me tell you, it's an extraction from lots of news channels and all. And they put the recordings, then all the voice and all together, and then actually it comes, that outcome is this, right? This completely based on neural networks. Now it's like hundreds of GB actually. So data that you see, the outcome, the lip syncing models. Way to lip is one of them, actually, a very popular model. Now one day I just thought, like, let's do that. I took few days to understand and all. Now I just came across 1 GB of data. Hardly 1 GB of data. And I thought, let's extract some voice and all, like voice images put together and all. Like, it took around 4 days for me to just extract and create a neural model out of 1 GB, hardly 1 GB data, 1 GB videos. So around 4 days, and my laptop was like burning like hell. Like, so that's a real experience I thought to share. Now I thought, okay, this is just hardly 1 GB data. What about like terabyte or petabytes? Because in these days, the data keeps on increasing, right? What kind of computation power? I reached out. I spent lots of dollars in onboarding some of the AWS instances. Even the biggest instances, company almost tried to grab my neck and try to throw me out because I was using lots of resources in order to process it. But what I realized is, like, as I got into it and I found that, okay, there's something called quantum computing, okay? Quantum computing, but still it is not, it is kind of experimental, though many giants say that, okay, we have attained the supremacy, but there are lots of disadvantages and advantages that will of course, go through it, right? So this is quantum computing. It's one of the revolutionary idea that is actually shaping our next few years. So let's start with this unblocking the future of computation, right? So let's understand the basics of computing. I won't bore you too much because I know you must be tired, and now quantum computing kind of topic, I'm sure you will be sleeping I can see lots of beds over around, right? So let's get started with I'll keep it very short, right? What is quantum computing? Let me present the slide. Sorry, is it? Slideshow, yeah. Is it visible? Yeah, thanks. Right. So quantum computing is, like, of course, the emerging technology that leverages the principle of quantum mechanics, the physics, very tiny particles like electrons and photons and all, right? Of course, quantum bit, like usually, like we see that any state occurs at either 0 and 1 in any technology, right? Whenever you're doing any computation, ultimately when it goes to a machine learning, it converts into 0 and 1. Now, suddenly I saw something that can exist in between. Like, okay, what is it actually? Like, I don't know. Like, so then, of course, then I came to know about that there's something called qubit that exists in quantum computing, that 0 and 1, there's multiple states that it can occur, right? And the point is, like, for example, like, of course, when it is under process, then it can occur in multiple states. But ultimately, when the results come, then of course it is always one state. But it's like in between, can exist in multiple states. So there are basically 3 principles of quantum. That is qubit, that is quantum, that's a basic unit. then superpositions and entanglements, right? So as I already mentioned, in traditional computers, we mostly move towards from 0 and 1, and then in this something came up like that is called exists in between 0 and 1, 0, 1, 1, like these states. Now let's quickly go through the core principles. Of course, I won't get into details, but like let's talk about the superpositions. Like superposition is a state in which the quantum particles or systems can represent not just one possibility, but a combination of multiple possibilities. So whether it's 0, 1, 0, 1, 1, 0, 1, 1, it can, while it is predicting or in between those processes, it can be exist in multiple possibilities. Now, if the possibilities is different states are connected with each other, right? As you can say, entanglements is a process in which multiple quantum particles are correlated. They are aware of it, that every state is aware of it, what the other state is. And together, they can do a multiple or billions of computations in one go. So like, just to take an example that you will see, like when you actually flip a coin, right, of course, is a head or tail, it can actually, when it is rolling, this is one of the states, there are multiple states it changes, so that in which the quantum can exist. When it comes to, I will talk about the interference first, because when this probability is increasing, like whenever we are actually, for example, in between 0 and 1, these possibilities are coming, these probabilities. Now the point is, like, it actually, of course, there are multiple amplitudes. I know that there are lots of things that may not make sense, so I will just jump onto the applications. But the point is, there's something called a constructive interference and the destructive interference in this. Like, for example, there are 100 possibilities. Now, in this quantum mechanics or quantum computing, it can actually disrupt or remove what I can say, that remove the possibilities that can actually give a false results, and actually increase the possibility of those probabilities that can give a positive results, or that can actually give you the results. So even on the fly, it can actually predict what will be the outcome. So another thing is that decoherence. Actually, decoherence is a process where we actually, because these are very small particles, right? These are very like electrons and photons we are talking about. Now, usually in order to make it work, it has to be in a very, very, like at the temperature, the environment that it requires is very, very limited, a very constrained environment, like almost absolute zero. There are many conditions that it requires in order to make it work. Apart from that, anything that, so it is very likely that it can get easily influenced, or it can get manipulated. The final results may get manipulated by the external changes in the environment. That's why even if we have even the Amazon, Google, or any Microsoft, even they are providing this quantum computers, the error rates are still very high because of this attaining this. Because like, who can carry a refrigerator here and there that has an almost absolutely zero temperature? I'm sure no one can. So when actually we are trying to, everyone is trying to actually reduce the size as much as possible, but it still is like a big chandelier. We always see those images when it comes to the quantum computings. Moving forward, like as I will just quickly like wrap up this particular slide, right? That is quantum computer, how it works actually. Like, of course, as I mentioned, like 0, 1, and in between 0 and 1 it can exist. What are the particles that we usually use, like photons and electrons? And as I mentioned, one of the conditions that is mentioned is -495 Fahrenheit or -273 degree. That is one of the conditions, favorable conditions, that it can exist and give you the favorable results. So this is a kind of diagram that you say when usually like everywhere, like. So it's actually, as I said, like it's the future of this computing, because like lots of streaming data, as we are increasing, like let me give you an example. A person is going to have a heart attack or any kind of a particular like, and it can predict, okay, within a fraction of a microsecond that yes, it is going to happen. Do we have any technology that can predict this? Maybe it can, right? So that is something that level, even with like a billions and cases or trillions of scenarios, it can, in a fraction of a second, it can process, because it is doing a parallel processing. Like, so like give an example, like if we say that we have a 10 qubit quantum computer. So we are actually talking about 2 to the power 10 possible states of that system that can exist at one time. So Of course, so jumping onto the advantages and disadvantages, let's talk about the advantages first, right? As I said, like it's about the superposition. It's actually tutored by n states. That's a lot. We have some of the is still existing algorithms, like when it comes to Shor or Grover's algorithms, but still it's in development that new algorithms to actually make it work, because like controlling the interference, controlling the possibilities in a so that it can give more probable results is a big task for a companies to derive such kind of algorithms. When it comes to the capabilities of like of course modeling quantum systems, which benefits material science, chemistries, drug discoveries, it's still like when we had a COVID, right? It takes many years actually, what I can say, in order to create a matured vaccine, because it takes under trials and all. Maybe once we have these kind of systems, it can predict the possibilities, and maybe in a day we have these kind of vaccines, if any kind of a diseases. So that is another like a good possibility, like a use case of this. Of course, when it comes to the like a cryptography, do you know what is the most like a secured encryption algorithm? Anyone? Like anyone knows? Let's talk about the AES 256. I think AES 128 is also quite heavy, right? And it takes how much time to decrypt? Maybe 10 to the power many years in order to decrypt it, right? Suppose there's a person who's a terrorist and who's trying to attack, and he sends a message in AES 256 and it sends to a different country, right? And we don't know how to decrypt it. Now, if we have these kind of systems, it can maybe possibly decrypt it in like a couple of hours, maybe not in billions of years. So this is one of the use cases, but of course it always comes with the merits and demerits. So it depends how the technology, every technology emerges, it always comes with good and bad things actually. So we always talk about the good things actually, why going into bad things, but that should be controlled, right? But of course, right now there are many disadvantages. Of course, qubits are extremely sensitive, scalable. It's not easily scalable. We usually don't carry a system that can actually process the electrons and photons like this laptops. It's not practically possible, at least these days, right? When it comes to like infrastructure, yes, we have a very strong limitation of the infrastructures till now. Jumping onto the challenges, I've already discussed some of them, like decoherence and noisy, as the quantum states are extremely sensitive because of the environments. Scalability, so like stable qubits generation is another big thing, because of the temperature it requires, making it stable under required conditions. And of course, having a small system that can carry it, these things, of course, it's a challenge. And another thing is that even if we get the errors in that particular computation, then also in order to correct it, we need more qubits in order to correct it. Because I was talking about the interference, positive and negative interference and all these things. Even for that, we need some additional qubits in order to correct it. When it comes to the algorithms, as we know that these kind of things, in order to control it, of course, we are still designing many new algorithms. We have very limited infrastructure, as I already mentioned. And of course, the classical systems, suppose one is moving at a light speed and another is still moving at a tortoise. So how the person can communicate in that, how the two systems can communicate, because one is going too far, and like, right? It's about the rabbit and tortoise race, right? Of course, I'm not going to discuss the Biard's algorithm right now, right? Let's talk about the current state of quantum computing, right? That we have currently, that is building a dedicated quantum stack, tackling hardware challenges that we already discussed, co-designing, and of course, fault tolerance architectures is still a challenge. That's why it is not, even it is required in a simulation stage. Even if you try different companies, that is, we have these companies like IBM, Google, Microsoft, Amazon. So these companies that is top-notch is providing, but still, as I said, there's always an error rate, and it's not very cheap to be used, right? And still, it's not, we don't see very, very likely productionized scenarios of quantum computing these days. Even Giants is not using, except those who has their own R&D cell. I will take just Google Quantum AI, known for achieving the quantum supremacy for its like one of the algorithms, advancing quantum hardware and software to develop practical quantum application. But how much it is stored, of course, we don't know. jumping onto the conclusion, right? Quantum computing is still, it's at an early stage. Even it's maybe, hopefully it is like 8-10 years behind, but like once it is achieved, maybe there are lots of things we can achieve. Despite its potential in quantum computing facing challenges, of course, qubit decoherence, error correction, scalability, and all these things are the problems we have. There are technologies, companies that we have already committing that they have attained, but how much? We still like, it's in progress. It's kind of still an experimental stage, not stable much. So it's not very much advisable, but like for still certain limited scenarios, for certain specific, very, very specific use cases, yes, we are still started using it, but still it's a future. And also like industries like pharmaceuticals, as I was talking about the vaccines and especially the medical sciences and predicting the outcome of you, like maybe like, for example, like cancer is one of the like deadly diseases. So maybe like it scans a person and maybe like it can predict that 20 years down the line, you will be having a cancer. So these kind of like innovations that we are talking about when it comes to the quantum computing kind of things. I know it's like it sounds like a Terminator kind of movie, but no, it's getting real. And once you go through its use cases and it just go through its Google, you will find that this is coming to be real. It's just a matter of time, right? And finally, the future of quantum computing depends on overcoming technologies hurdles and developing fault tolerance quantum systems, paving the way of real world applications and risk adoptions. So this is actually all about the quantum computing. Not, of course, it's just like a brief what I say, but yeah, it is a very interesting topic I'd like to share. Recently, I started trying to understand more and more. So I just thought even it's experimental research, but still it's still good to share. And I hope you guys can just go through it and see how it goes. Yeah. Thank you so much for your time. I hope I didn't bore you a lot.